5, 4, all right, 10, 9, 8, 7, 6, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and we are live. Hello world, it's Siraj, and welcome to the Let's Build Game Show. This is a weekly game show where you are not just the spectator, you are the player. In this week, we are going to be building an operating system, and it's going to be an operating system that uses machine learning. And we're going to do that in under an hour using several existing tools, all right? And so if you can answer my 3 questions as I build this operating system, you get the prize at the very end, which is going to be me freestyling a song just for you, and you get a Bitcoin prize. It's going to be $20 worth of Bitcoin that I'll send to you. Not that much, but we're going to increase that prize over time every week. That's my goal. I want to make this as fun and as engaging and as interactive as possible for you, because we have so much to talk about in this next hour. We're just going to start with operating systems. We're going to go to that next level, and that next level is called machine learning. So if you're ready, let me show you the demo first, because the demo for this thing is pretty cool. So let's bring up the demo. This is the demo. Okay, so what is this? What are we looking at right here? What this is this is an operating system binary that uses several parts. There are 3 parts to this. The first part is a neural network written in C++, a char prediction neural network, originally created by Andrei Karpathy, but later implemented by a different developer. His name is Kishore. And the second one is we used a kernel created originally by a guy named Mike, so Mike OS. And the third is we used a bootloader created by a guy named Arjun Sridharan, which is, so we're putting several different parts together here. We're putting a bootloader together with a kernel, together with a word prediction engine. And combining all those together, we call that Neural OS. So what this does is, all it does is it predicts the next likely character in a string. That's it. That's what this operating system does. It clears the screen, and then it writes out the next, it makes a prediction as to what's the next likely word in this sentence. And so we can just keep, we can just keep running this as ngram, and you can see it's just going to have the same outputs over and over. But if we go up and down, basically the training data, the testing data is basically like a bunch of words like hello world, it's Siraj, right, over and over again. And then it's just going to try to predict what that next word is going to be. And this is really a proof of concept to show how you can combine machine learning with an operating system. And there's several things that we can do to optimize. We can optimize space complexity. We can optimize time complexity. We can optimize energy usage, right? There's so many things that an operating system does, which takes us to the actual operating system. Let's get to the meat of this, and that is this operating system right here. And I'm so excited to show you this thing because we have so much to talk about in terms of operating systems. What you're seeing next to me is a diagram which describes what an operating system is in the hierarchy of objects in computer science. So we start off with some computer hardware. Maybe that's a PC, maybe that's a phone, maybe that's a virtual reality headset, maybe that's some device, right? Whatever it is, it's got a motherboard. It's using what's called von Neumann architecture, which is a combination of a motherboard, RAM. There's just so much to talk about here, but basically it's a computer. Now, that computer needs to do tasks. That's what computers do for us. They automate tasks. Now, back in the day, people would have to go to these giant data centers and manually operate these machines, right? So they were operating these machines by putting in jobs physically into this scheduler. So they would schedule jobs like add 2 + 2 or, whatever operations, one after the other. And they would have to manually operate this. This is very time consuming. We don't want to have to operate these systems. So eventually the idea of an operating system was invented to automate these tasks, like scheduling different tasks on a machine, thinking about where to store things like memory management, and then also just energy usage, right? So a bunch of things. And then on top of that operating system, once those things are taken care of, then and only then can we build the next layer, which are our apps that we care about, Uber, Airbnb, consumer-facing apps. And so that's the basic idea, right? Operating systems automate that complexity. But there's more to it. It's not just about automating, automating, memory and automating space and automating energy usage. It's also about automating what you see next to me right here, which, these things like file management, input, output, right? What are your peripherals, a mouse, a keyboard? How do we integrate that into the system? What does that look like? All of these things are a part of an operating system, right? How does the system operate? What are the necessary tasks that we want to perform unconsciously? So think of a computer like a mind in a way. That's one frame that we can think about it as, right? There's several frames. And so in your mind, you have these unconscious processes that are running, breathing, keeping your heart pumping, right? Your immune system, all of your endocrine system, all of these different systems. You're not thinking about them, right? You're not worried about them, but because they run, you're able to think about higher level processes like, emotions and things like that, whatever. So we can think of operating systems as a very similar analogy. So they can do any number of things, right? They can do potentially infinite number of things depending on what that system is. Now, generally for PCs and laptops, right, it's not much. It's like memory management, space management, basically the same thing. And then energy usage and so time and space complexity, essentially, right? All the different ways of saying time and space complexity, which brings us to our last image before we start looking at what I like to call assembly, or what is called assembly. And that's this image. Okay, take a look at this. Now, I don't want you to be afraid. Don't be afraid. Don't be afraid. I'm here. We're here together. This is a community. Okay, this is the Code Royale community. More on that later. What you're looking at here are two languages. You have assembly and you have machine language. So you and I know that there are these things called programming languages that we, type into computers. And then what computers do is that they will convert them into assembly and then machine language, ultimately machine language. Now, machine language is just ones and zeros, but assembly is one step above that. It's the intermediary step. And the reason that you see these letters interspersed with numbers, right? In assembly, you have things like, you have constructs like 0AH or, 4X, or 4J or something. Like basically you're mixing these numbers and letters together. And that's called hexadecimal. That's a base counting system that makes it easy for computers to compute large numbers in a very space efficient way. Because what we're doing when we are working with assembly, now, by the way, assembly isn't one language. Assembly is a different language depending on what your computer architecture is. So there are different computer architectures and there are different assembly languages for all of them. There's like x86, x64. This machine that we're working on is an x86 machine. So we're going to be working with the x86 assembly language, which isn't that complicated. It's actually just all we're doing is we're moving memory around. And so we're going to be building an assembly script from scratch. Okay, because that's what we're going to need to do to build an operating system. What happens is your computer, it boots up with the BIOS, right? The BIOS, the motherboard. And it's like, okay, what do you want me to do now? I just booted up. You just turned the power on. What do you want me to do? It will then look for your operating system. Now, your operating system consists of two parts. You've got a bootloader and you've got a kernel. Now, obviously, there could be more, but those are really the two main parts you need to function. Now, the bootloader is basically the part that says, this is the first part that the BIOS loads up. And it's like, okay, this is the bootloader. It's going to define how much space the kernel is going to take and a bunch of other things. And then the kernel is going to do it's the meat of your operating system. What does your operating system do? So, the Linux kernel is a popular kernel. It's also got a bootloader. And so we are going to look at one very simple example of an operating system before we build our own, and that's by Mike OS. So we're going to go through this assembly code. I don't want you to be afraid. We're going to go through this assembly code together, and then we're going to write some assembly, and then we're going to write some C, and then we're going to add some machine learning to that. All right, so we have a lot to do in this hour, but we're going to do it all. So I've explained all that to you, and so now we're going to look at the browser and what is in the browser. So let's pull that up. Where's the browser? I can't see my browser. Oh, there it is. Okay. All right. So in the browser, we're going to look at this. So if you Google, like, how do I write an operating system? This is probably the first link that's going to show up. And it's been around for 3 years now. So this is called Mike OS, developed by a guy named Mike Saunders. And it's a good starting point. You know, he goes through, I encourage you to read this at some point. He basically goes through the assembly language. It's a great primer on what all of these variables mean, like AX, BX. What is decimal? What is hexadecimal? And really, you know, a lot of the time, you know, 80% of the complexity is, you know, what is it? It's like the 80-20 rule. Like, you're only going to use these 5 variables 80% of the time, right? Even though there's many more. So, you know, MOV, add, CMP, JMP, and int. And basically these are instructions for assembly that tell us how to manipulate registers. And registers are physical locations on our computer's motherboard and, you know, chipset that basically defines where to store memory. And when we are programming in our high-level programming languages like Python and C++, we're not dealing with registers. We're dealing with storing variables in memory, in RAM, right? A lot of the times. We're not dealing with storing literally these physical locations. That's what assembly does. And assembly does it in the most space-efficient way possible. And I think we can all benefit from thinking about programming in this way. Like, basically, building an operating system is the final boss of any programmer, right? It's, if you can build an operating system, you can do so much more. So in this like 32-line demo right here, Mike gives us a good overview of what an operating system consists of. And so what I'm going to do is I'm going to read through this before we write our own assembly, just to give you some, you know, some high-level idea of what's happening here. So it's just this right here. Okay. So what's happening is we first say this is going to be a 16-bit system. So this is just a compiler directive. Like, what type of system are we running on? And then we have this start function right here. So all assembly programs have a start function. At the very start of this start function, let me make this even bigger. I want to make it even bigger for you. At the very start of the start function, we're going to define a certain set of space for the bootloader. Now, what the bootloader is going to do is it's going to store the first part of a kernel. Okay, so the bootloader is basically that first part in memory that our BIOS is going to read. And it's basically going to contain a bunch of like launcher code. Like, okay, we want you to launch this kernel, and we want you to clear this part of the system, and we want you to allocate this much memory. That's what the bootloader does. It's like the first part of the operating system. And so we want to set up some space for that bootloader. And so we set up a 4K stack space for that bootloader using this first line. So the MOV line basically says, here is this register called AX that's on the chip. Take this value in hexadecimal. It says 07C0H, which is basically hexadecimal for 4096. And that's how many bytes we want to allocate for this register in memory. Okay, and so once we've done that, then we're going to say, let's add 288 bytes to that space as well. So that way we're partitioning it per paragraph, which is just good for formatting. Once we've done that, we're going to, again, copy that value into another register, and then again to another register. And so by the end, we have this data segment, which is the first part of our kernel, which contains the bootloader. And in that bootloader, we're going to put the kernel. So the kernel is this function called text string. And the kernel, in this simple case for Mike, all it does is it prints a string to the screen. And that's the operating system. That's what Mike did. So we call print string, and then we have this infinite loop for, you know, however big the string is, we're going to print out all of those characters, character by character. And this is the input right here, text string DB, which stands for data byte. This is my cool new OS. Okay, and that's that line. And so in the print string function, we're saying print every single char of length. It's going to be 10. And this repeat function is going to be automatically called, where we're saying if the character is 0, this is basically a for loop right here, essentially the equivalent of a for loop, where we're just printing out every single string character in the string, character by character, until we get to 0. And at the very end, we have this cleanup code, which is just basically like memory cleanup, pad the remainder of it. And this is just like a standard PC boot signature. But in those 32 lines of code, Mike of assembly code. Mike wrote this operating system. There's no C, there's none of that. And so once you have this, you copy and paste it into an ASM file, an assembly file, and then you can run it from your terminal and you can emulate it using QEMU. So QEMU is one of the several emulators where you can basically emulate an entire PC on your PC. So you can run an operating system inside of your operating system and you can see the result, which is just going to say, this is my cool new OS. That's all his operating system does. But forget his operating system. He showed us a great example, and now we're going to build our own operating system, all right? So let me get to that. So how are we going to do that? Do you have some kind of assembly compiler? Probably not. So let's get to the first part of this. Let's start writing this operating system. We're going to start with assembly. Here is assembly. So mycompiler.io is a great editor, online editor for you to be typing out assembly. So what they've got here is they've got this start for us, okay? Here is the start for us. Got some starting code. And we're going to modify this. So here's what the code does. It starts off with, so there are two sections in every, there are actually, there are three sections in every assembly program. There's a start, there's text, and there's data. And so data is going to contain that input. It's going to be hello world. And then text is going to define basically it's like a main function. And so in this case, it's going to call start, which contains everything that we need. And, these are just registers that are being activated. And, the last one is going to be of size 13, which is how many characters are in our string. And so when we hit run, we get this output, which is hello world. Okay, so that's what that does. Now let's modify this to create our own operating system right here in the browser, right? So what do we want to do with this operating system? Well, we know that there's going to be a first section called data. And let's say that we want our operating system to do some string manipulation, right? Like we've already seen Mike do the print string with his operating system. So let's take that string functionality to the next level by manipulating a string. So how do we manipulate a string in assembly? So we've already got this start, and you can do this in your browser as well. It's at mycompiler.io. When I finish this, we're going to start answering questions. So in mycompiler.io, we're going to say, we don't need this hello world line. We have our own message. So we're going to say, we're going to call it M1, and the input is going to be begin. So we just want this begin function to start. So it's going to say begin, and we're going to give it some, we're going to give it two addresses to be stored at, 10D and 13D, because we're going to have two different words that we're going to use here. Okay, and so we want to subtract some character from that string. So in order to subtract it, we're going to say subtract M1, and let's see what happens when we do that. Message undefined. That's right, because we have message being called. Where's message being called? Message on line 12, right here. That's right. So we want to call this M1, not message. So we'll call M1. Okay, so we say begin. So we didn't really subtract anything from begin because there was nothing to subtract. So now we're going to subtract a string from it. So we're basically doing string manipulation here, where we're going to say hello world, and that's our first string. And again, we're going to put it in the same location. And it's Siraj. Let's just do that one more time and see what happens. In the same location, and then if I do a subtract, then it's going to print a string which is half of, it's just going to say hello. It should just say hello. It should take off the world part and the it's Siraj part. So let's see if it does that. Okay, there is our initial string manipulation. Now notice, it said begin and then it says hello. Now it doesn't say hello world, it's Siraj, it says hello. Why? Because we have this equals -3 functionality line right here, which says replace that part of the initial string with what we've just initialized here. And so this right here is an operating system written in pure assembly. Like this is basically the kernel is just this line, right? Kernel is just like a synonym for functionality in this case. So we want to take this thing to the next level, right? We don't just want to write some assembly. We want to write some C and we want to integrate some machine learning. So let's do that. Before we do that, let me answer some questions because we have some questions to be answered here. We also have a question for, I also have a question for you. So let me pull up my question for you. My question for you is, let's pull that up, Q&A. I know you guys are working on this. So I want you to go to itempool.com/ll/source/ll/live. I have begun accepting answers. And while I accept answers, I'm going to answer questions. So let's answer questions. What do we got here? Question 1. Are you writing a kernel? Yes, we are writing a kernel. And you can see the people who are answering. Let me also, there's so much going on here. Let me read the question that I just put up for you. The question is, which subfield of computer science can see performance improvements from machine learning? Is it A, computer graphics? Is it B, quantum computing? Is it C, biometrics? Or is it D, all of the above? That's the question for you. I want you to think hard about that. We've got 2 people who've answered it so far. We've got 2 opposing opinions. Let's see what they think. Am I writing a kernel? Yes. Do you need complex math to make an operating system? No, you absolutely don't. I just like complex math. We need to learn some complex math here, okay? Math is extremely cool, okay? And it is the future. And in the future, in 30 years, in 40 years, those who know math the best are going to be the top, the most glorified people in human society. Because I don't care about where we are. I care about where we're headed. That's what I care about, the future of humanity. And so, I have a lot to talk about that in a second, but we have some stuff to talk about. So why is anyone not making any operating systems today? That's what we're doing, Sparox. We're making an operating system. And I told you the tools we use to make it and the authors who built those tools, right? We are being legit here. This is just you and me. This is not, there's no editing happening here. This is all live. I love you. Okay. So, last question before we keep going. Do you need to know, need an idea on a Python-based project? Rakshit, let me give you 2 ideas off the top of the dome. Idea number 1, make an operating system that uses machine learning to optimize energy usage. Energy usage specifically. I think there's a great usage for energy usage for GPUs, and there's a great idea for that. And then the second idea for you is use Python and machine learning to build an emotion detection engine for virtual reality, because that's what's going to happen next. That's the path to AGI. We have so many people who are answering this one question, so let's see what the answer really was. All right, here we go. Answer time is over. Finish and reveal. The answer was D, all of the above. Congratulations, whoever got that. I love you. Let me play my Victory Royale sound effect that I worked so hard to make work this live stream. We are going to play the sound effect, come heaven or high water, whatever it is. Here we go. Victory. Good work if you got that right. Let me play that sound effect. Good work. You got that right. If you got that right, you're amazing. I love you. All right, let's keep going. Right. All right. So that was that question. And now we have to keep going. So let's go back to what we were doing. So what we're going to do next is we are going to look at a paper. We're going to add some machine learning to this operating system. So that's our next step. We got to read this paper. I got to read papers to try and make me smarter. I train my models in the cloud now because my laptop takes longer. I parse through data like a boss now. Back then my code was wronger. Subscribe if you want to learn now. I want you to scream that last line if you know it. Let's spread that AI power. Yeah. All right, let's keep going. How to write a simple operation. What are we doing here? We are looking at this paper. Look at this paper, everyone. A survey of machine learning applied to computer architecture design. That's exactly what we want to look at. That's exactly what we care about. A survey of machine learning applied to computer architecture design. So what I want you to do is at some point read this whole paper, because there's not much math in this. It's mostly just ideas, so many different ideas as these authors go through this paper, and they look for all the different ways that machine learning can be used to optimize computer architecture design. And, look at this chart that they have right here. This chart just shows the number of papers in ML for computer architecture design over the years. And notice how it's just exploded in the last 3 years. So there's a lot that they go over in this paper. They go over energy optimization, CPU optimization, memory storage optimization, feature optimization, task allocation optimization, scheduling optimization, classification of different tasks, branch prediction. There's a lot going on in this paper. Okay. And so where do we begin with this? And so I've got a great start on where to begin with this. And, I have a second camera for you. So you can see what I'm talking about here. All right. And in the second camera, we're going to be writing out some math. So before we write out some math, we have Suraj's weekly 5-minute AI speech. I'm just going to give you a speech of just what's been going on in my head about artificial intelligence and what I'm thinking about the future, all right? And applied to operating systems and machine learning specifically. Check this out. I know the path to AGI, and I will tell you how to get there. I see it before us. GPT-3 is a language model created by OpenAI. GPT-3 was trained on a lot of high-quality data from Reddit. Okay, it was trained on a lot of high-quality human data from Reddit. All that GPT-3 does is it's a next word prediction engine. It can predict text that looks really human in a bunch of different contexts. It can also generate code. It can generate code as well, which is the end game. But the point is that GPT-3 was trained on what you and I consider high quality human data. But I'm here to tell you today that Reddit is not high quality data. High quality data is happening in a place called virtual reality. And this is the Oculus Quest 2 device. This is my favorite new device right here. I'm now in virtual reality, and now I'm back. Welcome back to base reality. I am a part of the Facebook Horizon closed beta. I got access to it. And inside of Horizon, I have been doing so much in terms of creation, right? So I've been building with Unreal Engine. I've been building with Unity. These are game simulation environment creation engines. In Horizon, you can do this with your hands with full tactile precision. And they've even got this drag and drop visual scripting language you can use for building levels. It's insane. The point is that and Horizon's going to be huge next year, all right? I know, a lot of people in the world don't have access to this virtual reality headset. That's why I don't like to talk about it too much. But they will next year. It's just a matter of time. And next year, we're going to have hundreds of thousands of people interacting in these virtual worlds. Okay. And hundreds of thousands of people are going to be interacting in these virtual spaces with their hands, hand gestures, emotions, right? Emotion detection. When you take a language model like GPT-3, okay, and you put it in an avatar in a virtual space, okay, this has already been done, but you put it with humans, right? Human players, and you have it trained in a reinforcement learning context with other humans. That is how we get to AGI. This language model is not just learning how to speak human language. It's learning how to interact, how to gesture. It's looking at your emotions. This is a multi-agent, cooperative, and competitive reinforcement learning problem, okay? And so that's the key, and that's how we get there in 5 to 10 years. I wrote a book called Decentralized Applications because of how much I hate Facebook and how much they are taking over. But let's just be real. They are pivoting away from newsfeed. Virtual reality is the future of computing, and it's also the perfect testbed for these artificial intelligence algorithms. And so we are not in an AI winter. I was arguing last night with some people, some developers. We are not in an AI winter. I wish we were. I wish I could say we were, because I don't want to keep coming back to this. I don't want to keep coming back to deep learning. I want to talk about something else now. But every year a new metric is broken. I can't. It keeps pulling me back. I will be the last one here talking about machine learning when everybody else is gone. I will be talking about this until my last breath because it matters. It's all I care about more than anything. And it's fun. And I need you to understand how powerful this technology is and where we're headed. Operating systems, compilers, think about the videos I've been making every week out here. These are rule-based systems. All of them are going to be learning algorithms eventually, all of them from the top to the bottom. And what we consider the software stack is just a collection of rules. But eventually, as machine learning takes over, as machine learning is adopted in all of these scenarios, from databases to operating systems to compilers, all the way up to application level processes to network design, it's going to stop looking like a stack. It's going to stop looking like a set of components. And it's going to start looking like one giant learning algorithm from top to bottom, the master algorithm. And that's where we're headed. The future is about to get really weird, guys, but together we're going to go through it in a beautiful way. All right. So let's start writing some math. All right. Let's start writing some math, because I need to show you what I'm talking about here when I'm talking about GPT-3. So let me pull up my second camera here. Let's see, the second camera for math. All right, here we go. Math cam. Here we go with math cam. Here we go. Math cam. All right. We got math cam up. Yo. All right. Math cam. Here we go. Let me move my hand. All right. Here we go. What are we going to write? So let's say we have an operating system. Now, how are we going to think about our operating system as we design it? Are we going to think about it the way that Mike OS thinks about it, or how anybody else thinks about it? No, we're going to think about this as a reinforcement learning environment. That is what this is. This is a reinforcement learning environment. And what that means is that we are building an AI. Think of our operating system itself as an AI, a learning system. And in order to do that, we need to frame this problem as a Markov decision process. And if we do that, then ultimately we can learn what's called the state value function, which looks like V, given the policy, given the state. So that's what we're trying to learn, this function right here, this function right here. That's what we need to learn. And if we can learn this state value function, what that means is our agent, given any state, it's going to know what action to take to maximize the reward. Now, what is a state in this case? In this case of an operating system, the state is going to be how much memory is in a certain location, how much CPU is being used, right? These are single number scalar values, and we can optimize in any given direction or all of the directions. And so given this reinforcement learning context, given this state action function, what does this look like in practice? Well, what this is going to look like is it's going to be a collection of, and that's what sigma is for, it's going to be a collection of every single action we've taken up to this point where time is greater than or equal to 0. And then we have a discount factor as well that's going to be added to that. Now, why do we add this discount factor? Because the discount factor is basically a way to say how much reward should matter. So maybe in the far future, rewards will matter less. So let's just say we're trying to optimize energy. Over time, there's like this decay in energy usage where if your GPU is using 100%, if you're using 100% of your GPU, then you're going to have some problems. Your system's going to freeze, you're going to have some problems. So you want to stop before you get to that point. So, we can think about decaying the reward in that sense. Do something when you get to 90% CPU, not when you get to 100, but definitely do something when you get to 50, right? So there's like a decay in terms of priority. And that's what this discount factor can help with. And it's just a way of representing that, okay? Times the reward given a state, starting at state 0 up to how many states given a policy. And the policy is defined by this pi value right here, okay? So that's what we need to be thinking about. Fuck everything else. We're here to build a reinforcement learning agent and call it an operating system because our brain is an operating system. You need to be thinking about this a different way. Now, I need to now ask you a second question I've got. And you know, let me ask you the second question. Here we go. The second question, transition, is going to be, what does an operating system not do? We just talked about what an operating system does. What does it not do? Is it A, memory management, B, scheduling, C, storage allocation, or D, package management? I want you to answer that, all right? Let's see what people are answering while I answer some questions. Okay, what are your thoughts on XRP? So look, I know the guy who made XRP. We met up in San Francisco years ago. We all laughed at it back then. And I honestly, do I still laugh at it? Yeah, I laugh at it. Look, what I mean is like, is it a good investment? I'm not the person to answer that. Even though I wrote decentralized applications, the crypto space has changed so much since I cared about it a lot. I don't know. It's like, look, I'm bullish on crypto. Crypto's not going anywhere. It's just not going to be like the decentralized, anarchist thing that we thought it was. Like my friend Brian Armstrong is a billionaire now, right? He's the CEO of Coinbase. That's what's going to happen to the people who are really into crypto and who are building systems around it. They're going to get really rich, and they're going to be a part of the larger banking system. Like we are just adding functionality to the existing payment system. It's not going to be some like, some crazy new thing. But it is the start of these virtual worlds. Like virtual worlds will have their own currencies. How did he add a dark theme for the browser? Abhishek, I honestly don't even know. I've been trying to go back, but I don't know how I did it. I was like messing around. I'm waiting for an AGI to replace capitalism. Look, let me tell you something that I'm not going to say in person in any of the debates I'm having. The capitalism, socialism dichotomy is irrelevant for me because I don't care about either of those. I'm not voting for anybody out here. All I care about is fully automated luxury gay space communism. Okay? It's like a meme at this point. It's like Star Trek. We want to get to a world where we are just so machines automate everything. Okay, there is no money. We are just abundant with resources. And all we do, you and I as humans, is we play. We play, we create, we discover, we, have meaningful experiences together. That's where we're headed. Last question before we get to answering this. Suraj, how did you free yourself to have time to do stuff like you like to do? What amount of money is fuck you money in your opinion? That's a great question. Now, wow. So this is a process, like, right? So where do I make money? I make money from YouTube ad revenue. I still make money from book sales, from decentralized applications from years ago. I make money from my patrons. I love you guys. Am I out here making, fuck you money? No, I'm not making fuck you money. And, my friend Ryan invited me to St. Bart's last week to go with a bunch of his like Insta model girlfriends and like party. And he's done that several times. And I love Ryan, but I always say no because, I lived in LA for a bit. You guys probably know I lived in Santa Monica right on the pier. I was paying $6,000 a month for rent right on the pier, like right on the beach. And, after a few months, I realized I was unhappy, because places attract a certain value set. And those are just not my values. I don't care about like being super, super, super flashy in terms of unless it's devoted to education. That's something my mother taught me since I was young. Like you just need to study, you need to educate yourself, and that's how you're going to get out of this. And so I've really held that value deep inside of me. And that's really what I'm out conveying to the rest of humanity and putting out into human consciousness. Like we need to value education, we need to study, and we need to play. We need to have fun while doing it. All right. So to answer your question, am I free? I am free because I have lowered my expectations of what a good life is. All I need, Aliwe, to be, fuck you free is like, a place to live and a computer to have access to, like food. I make my own food. You don't need much. You don't need much to be happy. Seriously. You need like 2 or 3 great relationships in your life, people who you can, really say anything to and you can feel safe and vulnerable with. And you need enough money to, I'm not a millionaire. Let me just say that I'm not a millionaire. But from crypto and different investments I've made, enough to not have to think about money, and I can just focus this. Like, the prize at the end of this is just me, but like I'm going to get a sponsor. I just need to get the time to do that. I don't want to go on too far, but guys, I know that financial freedom is extremely important to this audience, and it's probably the most impactful thing that I can give you with this knowledge. Don't think that I've forgotten that. I just want to do it the right way. I want to do it in a sustainable way, in a 10-year way, not in a 3-month way, not in a 3-month course. I am here for you. I'm not going anywhere. Until my last breath, I will be here. I will be the last one here. I love you. Seriously. You are the reason I wake up in the morning and want to do this. Like the fact that you'll listen to this stuff, my ramblings about AI, I love it. So let's answer this question, guys. I don't want to get too emotional. Let's see what the answer was. Package management. Yes, that's what I like to see. Package management. Who got that right? Who got package management right? That's what I like to see. Congratulations on getting that one right. Victory. So close. All right. And now what I'd like to do is I would like to, let's build our operating system. That's what we have to do. We have to build our operating system. So, okay. Next. Okay. Operating system time. So here we go with our operating system. We're going to combine these ideas together. Okay. So where do we start? Where do we start with our operating system? Like we know the basic ideas. We know that we want to do string manipulation. But where do we begin? That is the question. So where we begin is right here. So Arjun created this kernel. So remember, I said an operating system consists of a kernel and it consists of a bootloader. And so let's look at this code right here. So we're going to build off of this. We're going to add some machine learning functionality to this right here. And then we're going to add our assembly code to it as well. So let's see. Let's go up. Okay. So we start off, this is just 23 lines of code. We're going to go through all of this. So again, what's this first part? I want you to know what this first part is. This is the bootloader. It's just allocating enough space in memory to store the initial part. So that's a bootloader. And then we get to the start function. Remember, there's always a start. And then that start function is going to be externally defined in a C file. It's called kmain. So this is a C function that we're calling from assembly. Badass, right? In the start function, we then set the stack pointer and then call it and then halt and then clean up. So let's go to C because this is all just the bootloader, right? In the C file, we can define the kernel. Now, what is the kernel that Arjun wrote? What is the kernel in C? Because we're going to have to replace that kernel with some machine learning. So the kernel that Arjun wrote is one function right here called kmain. And all it does is in 40 lines of code, he defines this initial string called my first kernel. He then allocates enough space in memory to store that, just character by character, like blank characters. And then we write that string to video memory in the last loop. That's it. So what are we going to replace that with? Well, we are going to find a next word prediction recurrent network. Now, Andrej Karpathy originally wrote the blog post I've talked about to death called The Unreasonable Effectiveness of Neural Networks. But Kishori here has this great implementation that is the smallest that I found for a recurrent network, which I love. Now, recurrent neural networks, what are they good for? They're good for predicting the next element in a sequence. It's a sequence learning neural network. And I'm not going to explain recurrent networks. I have entire videos dedicated to that. Again, search Siraj and then whatever computer science topic you're interested in, chances are I've got a video on it. That's what happens when you do this for 4 years. So we want to replace that kmain function with this. That's it. And so this is our way of implementing machine learning inside of a kernel. So what do I got? So I've got Ubuntu running on my Windows machine, and I want to show you Ubuntu right now. So let's bring Ubuntu up. Ubuntu. Guess what? My mom is born in Africa, even though I'm Indian. So that makes me African American. Life is crazy. Life is absurd, guys. So this is Ubuntu. It's running on Windows. You can get this on the Windows Store. It's for free. But as you can see, we can start with pulling mkernel. So we'll go to mkernel and we'll clone that into Ubuntu. We'll go into Nano, into the text editor, and we're going to replace that external kmain function with the word prediction engine. And so we can say code. There it is. We're going to clone it into this repository. So git clone. There it is. Boom. Cloning. And you saw the demo was right here. It's already precompiled, but we're going to reclone it. Downloading. All right. So that's our file. And then let's look into testing and training set. So inside the training set, you've got a bunch of training sentences. Like it's going to use these sentences to predict what the next best sentence is going to be. And so we can replace that training set with whatever data we want. And then again, in that kernel.c file, nano kernel.c. Wait, where's kernel? Where's the kernel? Oh, nano main.c. Nano main.c. We can modify it to include the neural net. And we can also clone that neural net into here with, right? So this is just pulling different pieces together. A lot of times integration is a huge deal. While that's downloading, I have a last question for you, and now it's in the file. And then we can just like run ngram, which adds some extra stuff. How can I earn via crypto? Okay, let me answer your question. Hold on. Let's begin accepting answers. And last question, guys. Where's that last question at? The last question for you. I need you to answer this question. Which of these is a square matrix of second order partial derivatives? Whoa, you didn't think I'm going to hit you with this question, did you? But I'm going to hit you with this hard question. Is it A, Q-learning, B, policy gradients, C, Monte Carlo, or D, the Hessian? That's what I have for you here today, right? What am I even talking about, right? If you know what I'm talking about, wow, 4 people already know what I'm talking about out here. That's what I like to see. Guys, calculus, linear algebra, statistics, probability, linear regression, right? Machine learning. It's actually very simple. All this stuff. You just need to know the basics. And, my team, we're developing a game right now. This is a game. I'm priming you guys for, basically education out here. Like, if we can get you guys like work, jobs, money, internships from playing these games, these computer science games, that's a really interesting proof of concept. So just to be completely transparent with you guys out here, I'm out here trying to evolve the future of education. We are all a part of this collective experiment. Let's see how fun can we make education? How high quality can we make this? We're going to iterate through all the feedback, and we're going to make it as good as possible. Wow, you guys are really all over the place here. Clearly, one subset of players here think that one of them is the correct answer. We're now going to reveal it. Ready to reveal the answer? Let's reveal the answer. Bum, bum, bum. Here we go. The answer is the Hessian. The Hessian, yes. The Hessian is a second order partial derivative. We use it in the Newton's method, for example. Anytime you take the derivative of the gradient, which is already a collection of values, you get the Hessian. And then there's the Jacobian. So you can just continually take the derivative of the derivative of the derivative of the derivative. And there are great use cases for this in inverse kinematics for robotics, for example. You use that for, however many degrees of freedom you're trying to predict where each degree of freedom is going to be in XYZ coordinate space. And so you'd have to compute things like the second order partial derivative. And the rest of those algorithms are just reinforcement learning algorithms. Q-learning is trying to learn the Q matrix for the state action space. Policy gradients is using the gradient as a direction in how to update itself, which is basically a difference in its prediction versus its error rate. And then Monte Carlo is essentially random sampling. And it's used everywhere from CERN, which I visited and talked to about, to all over the place. Okay, so those are the questions. I need to see who's the winner now. I need to see who won this. View the results. Who won our little game out here? While I answer some questions. Before I declare the winner, let me answer a few remaining questions. Okay, so remaining questions are: what keyboard do you use? It's a Logitech. It's like $20, guys. I'm not like rich. I don't know why Siraj Raval net worth is like a thing on Google. I just don't understand. I mean, I get it. Like, I have been doing this for years, but I'm not like rich, unfortunately. I don't want to be rich. I don't need to be. Like, I just need enough to do this. This weekly is enough for me. How can I earn via crypto? This is a way to earn via crypto. I want to continually give you more opportunities to earn money, by the way, whether it's through the rewards that I'm giving you or, partnerships with companies. Like, guys, I have a plan. I'm not just out here having fun. I am a man with a plan. If you know me, no matter how much, hoorah and flamboyancy and whatever else I'm putting out there, underneath it all, I have a long-term plan. I have a 10-year plan for us. Your book is too costly here in India. Would you like to plan a giveaway for it? Guys, go illegally download my book. Go find it for free. You have my permission. Go search Siraj Raval PDF free decentralized applications and go read it. I don't care. Last questions. Can you make some data wizard swag? Guys, I have so much swag coming out, but we got to get Code Royale started. Code Royale isn't just a game. It's a state of mind. It's an aesthetic. It's a way of life. I have so much encoded in my mind. I've got to spread out to you. I have so much to update you on the future of humanity and artificial intelligence and everything I've learned from Unreal and on Unity and Facebook's platform and Clubhouse, this stupidly exclusive app that I don't even want to talk about because I want you guys to be in it. But really, we are all going to assume a certain level of interactivity in all of our online conversations, and static content is not enough, and especially for education. So if you're trying to, figure out the future of education, welcome to the classroom. Let's see who won this. I am now going to announce the winner of this live game show. The winner is the first person to answer all of them correctly was Faison. Faison, how did you do that, man? How did you answer my super hard questions? Like, what kind of genius is this Faison? Faison, bro. What? I'm dumbstruck. I don't know what to say. Faison, you just won Victory Royale. Everybody, shout out to Faison in the comments. Everybody, shout out to Faison. Faison, I got a song I'm going to freestyle for you right now. Okay? And I need somebody to shout out a topic as well. What's a topic that you want me to freestyle along with Faison? Go. Here we go. Now, hopefully I get it in time because I'm going to play the song. Here we go. It's a time for the award ceremony, everybody. It's time for the award ceremony. You know what that means? That means that I have to dedicate this song and this video to my boy, Faison. Faison, you win the cash prize as well, $20 worth of Bitcoin. Email me, hello@sirajraval.com with your Bitcoin address, and I will get it to you within 24 hours, all right? And the best part is, here we go. Let's launch this. It's called Victory Royale. We about to freestyle. Here we go. Where we at? Where we at? Where we at? Yo. Listen, Faison, you answered my questions. You got everything right. How did you do that, man? I like to see what's in you. I like to see that kind of fight. Faison is the one to answer all my questions. I know that every single algorithm is in reinforcement. We We'll build this operating system, every single byte in the throat. Assembly of languages together with C. We grow energy. Faith, I'm moving back with every single value state function. I do it cause it's like my junction. They cross like it's a train, luxurious. Algorithms through the code. We make every single thing go in the toad. Nematode, psychedelic toad. Take you to the mind, to a free place. I want to scream a little bit. All right. Faison, I hope you like that mixture, experimental mixture of rap and rock and metal and screamo. I wanted to add some Sanskrit screamo in there as well, but I didn't have some time. But you know how it is. We're trying to redefine reality, redefine notions of identity, redefine artificial intelligence. That's where we're at. I hope you like this live stream. Faison, shout out my bro. This whole video is dedicated to you. Everybody in the comments, congratulate Faison forever. Listen, this is a community, everyone. So after this stream ends, I don't want you to just leave. I want you to connect with each other. I want you guys to get each other's contact information, connect with each other, learn with each other, find a study buddy, all right? Because you can't do this alone. We need each other, all right? This is a journey, all right? A learning journey. And so I love you guys so much. Thanks for being here. Like I said, I'm going to do this every single week. And I encourage you to study 1 hour of machine learning this weekend and do 10 pull-ups for me as well, all right? I want you to do at least 10 pull-ups. If you can't do 10 pull-ups, then I want you to do at least 1. All right, do that for me. If you love me, I want you to study machine learning for 1 hour and do 1 pull-up. All right, I love you too. Not to guilt you into doing something, but like, you know how it is. It's just for your own benefit. All right, guys, thank you for being here. I love you, and I will see you next week. And remember, be yourself. Love you.